The ground under your feet is not as still as it feels. At the equator, it is racing eastward faster than a commercial jet, carrying cities, forests, oceans, and the air above them around the planet once every day. You do not notice it for the same reason you do not feel the speed of an airplane when it flies smoothly. Everything around you is moving with you. Now take that motion away, not slowly over millions of years, not by a gentle cosmic break. In the most brutal version of this thought experiment, the solid Earth simply stops turning while everything not welded to the planet keeps its original speed for a moment. The result would not look like sunset. It would look like the world suddenly discovering it had been moving at more than 1,600 kilometers per hour. Stopping Earth's rotation is not like pressing pause on a globe. Earth is not a rigid toy. It is rock, water, air, ice, molten metal, and living things, all held together by gravity and all sharing rotational motion. Near the poles, the ground moves slowly around the axis. Near the equator, it moves fastest. That means the disaster would not be equal everywhere. It would be worst in the tropics and less violent near the poles. If the ground stopped instantly, the atmosphere would keep moving east. So would the oceans. So would anything not deeply anchored. Buildings are strong against gravity and wind. They are not built for a planet-sized horizontal shove. Near the equator, the air would slam across the surface at roughly the speed of a supersonic storm. The word wind barely fits. It would be a moving wall of atmosphere full of dust, trees, debris, and ocean spray. The oceans would be even more terrifying. Water has inertia too. If the seafloor stopped beneath it, the water above would surge onward. Coastlines facing the wrong direction would not experience a normal tsunami, where one wave arrives from a distant earthquake. They would face whole ocean basins trying to keep traveling east. Islands would be swept over. Continental shelves would become launch ramps for water. Low-lying regions would disappear under violent, fast-moving seas. But that first catastrophe is only the opening act. After the initial motion, Earth would have to settle into a new shape and a new rhythm. Right now, Earth is not a perfect sphere. Rotation makes it bulge at the equator and flatten slightly at the poles. The difference is not tiny on a human scale. The equatorial radius is more than 20 kilometers larger than the polar radius. That bulge is not a mountain range you can climb. It is spread across the entire planet. The oceans are part of that rotating shape. Sea level today is arranged around a spinning Earth. Remove the spin, and the balance changes. The centrifugal effect that helped hold water outward toward the equator would vanish. Over time, water would migrate toward the poles. The map of the world would be rewritten. Much of the equatorial region could become dry land, forming a broad belt of exposed seabed and connected continents. Meanwhile, enormous polar oceans would grow deeper, swallowing northern and southern lands. Places that are now far inland could become coastlines, while today's tropical seas could drain away. This is one of the most visual parts of the scenario. A stopped Earth does not simply have the same oceans sitting under a longer day. It has different oceans, different coastlines, different continents. The familiar blue planet becomes a planet with a giant equatorial land belt and two huge caps of water. The sky would change too. A normal day happens because Earth spins once every 24 hours relative to the Sun. If Earth stopped rotating relative to the stars, but kept orbiting the Sun would crawl across the sky over the course of a year. A place on the surface would not get morning, noon, evening, and night every day. It would get something closer to months of daylight, followed by months of darkness. That alone would be devastating for climate. On the sunlit side, the ground and oceans would heat for weeks and months. On the dark side, heat would radiate into space for just as long. The temperature contrast between dayside and nightside would become extreme. The planet would still have an atmosphere, so heat would not remain perfectly trapped on one side. But the winds created by that contrast would be immense. Weather would no longer behave like the weather we know. Earth's rotation gives moving air and water an apparent bend called the Coriolis effect. It helps shape trade winds, jet streams, rotating storms, and many ocean currents. Without rotation, air would tend to move more directly between hot and cold regions. The elegant spirals of hurricanes would not form in the same way, because their rotation depends heavily on the Coriolis effect. But that does not mean the weather becomes calm. It becomes simpler in geometry and more extreme in scale. Instead of familiar bands of winds and rotating storm systems, the planet would be dominated by brutal flows driven by the long day and long night. Air heated under months of sunlight would rise. Cold air from the dark side would sink and push outward. The boundary zones between them could become permanent storm highways, shifting slowly as the sun's position changes through the year. The atmosphere would be trying to move heat around a planet that no longer gives it a quick daily reset. Life would face several different disasters at once. The sudden stop version is almost unsurvivable over large areas because of the initial inertia. But even if Earth somehow slowed down gradually, avoiding the first global blast, the final world would still be hostile. Plants evolved around daily cycles of light and dark. Many animals use those cycles to hunt, sleep, migrate, and reproduce. Human agriculture depends on predictable seasons, rainfall patterns, and temperature ranges. Months-long days could cook soils dry. Months-long nights could freeze landscapes. Crops would fail in regions that had supported civilizations for thousands of years. The best refuges might not be where we first expect. The new coastlines would matter. Elevation would matter. Distance from the day-night extremes would matter. The atmosphere and oceans would keep moving heat, so the planet would not be divided into a clean half of fire and half of ice. But stable, livable zones would shrink and shift. Civilization, if it survived the transition at all, would have to rebuild around a climate no one had ever farmed, engineered, or governed before. The loss of rotation would also affect the oceans in a second way. Today's ocean circulation is shaped by winds, temperature, salinity, continents, and Earth's spin. Take away the spin, and currents reorganize. The great rotating gyres of the Atlantic and Pacific would not function as they do now. Heat transport would change. Nutrients would move differently. Marine ecosystems, already hit by changing coastlines and violent mixing, would be pushed into a new planetary ocean system. Then there is the interior of Earth. Rotation does not single-handedly create the magnetic field, but it is part of the physics that helps organize motion in the liquid outer core. A stopped Earth would not instantly switch off its magnetic field like a lamp. The core has its own momentum and complex fluid motion, but over long timescales, changing the planet's rotation could alter the geodynamo that protects Earth from part of the solar wind. That would add another slow, serious problem on top of the immediate surface disaster. The moon would still orbit Earth. Gravity would still pull the oceans into tides. Earth would still orbit the sun. Seasons would still be influenced by axial tilt. The planet would not fly apart, fall into the sun, or lose gravity. Those are the easy myths to dismiss. The real danger comes from something more ordinary. Inertia, heat, water, and air refusing to behave as if the ground's sudden stop were their problem. There is also a less dramatic version of the question. What if Earth gradually slowed until it became tidally locked to the sun, with one side always facing daylight and one side always facing darkness? That is not exactly the same as simply stopping relative to the stars, but it points to the same lesson. Rotation is not just a timer for sunrise. It is part of the engine that distributes energy across the planet. Change that timer enough, and climate, oceans, winds, and biology all become something else. The frightening thing is how invisible rotation is. You can stand in a field, pour a glass of water, watch clouds drift, and feel still. Yet the shape of the oceans, the structure of storms, the length of a day, the paths of winds, and the comfort of a sunrise tomorrow all depend on that motion continuing almost exactly as it does now. A spinning Earth gives life repetition. It gives the planet a pulse. Day warms the surface, night cools it, and before either side goes too far, the world turns again. Winds curve, oceans circulate. Clouds form patterns that satellites can track. The system is chaotic, but life has learned to live inside it. Take away the spin, and Earth does not become a quieter planet. It becomes a planet with too much time, too much daylight, too much darkness, too much heat building in one place, too much cold building in another, too much ocean moving toward a new balance, and too much atmosphere trying to catch up with a world that has changed the rules underneath it. So if Earth stopped rotating, the first disaster would be speed, the second would be water, the third would be climate, and the longest disaster would be the loss of the daily rhythm that makes this planet feel normal. We often think of Earth as our home because it has air, water, and land. But just as important is the fact that it turns. Every sunrise is not just a beautiful view. It is proof that the machine is still running.
Thanks for watching! If you enjoyed the video, please like, subscribe, and leave a comment below. See you in the next one!